Surface Modelling in Petrosys PRO. Highlights. Petrosys offers users unrivaled control over the gridding of their data. We make all relevant data available. It can come from multiple sources, including interpretation systems, GIS, and flat files. All data will be read directly and coordinate converted on the fly if required. Petrosys also has an algorithm to automatically convert fault sticks to fault polygons. This will require little, if any, manual editing. Data can be graphically edited before grid creation in a variety of ways, in both a histogram and in a map view. Bad data points can be removed, and additional data points can be digitized to help guide the gridding in areas with sparse data. There are also gridding algorithms that utilize user knowledge and experience. For example, on the left we have an example of our boundary gridding, where the software automatically creates a grid with a realistic zero edge. And to the right, we've used the biased polyline to accentuate some channels and make them more prominent within the output grid. Petrosys also has an intuitive spatial editor which can be used for many functions, including localized regridding. When the user makes changes to contours or faults, they can control which area of the grid will be updated, and those areas where the data is good are left unchanged. Accurate depth conversion regardless of data availability or source. You can work with SegY or ASCII stacking velocities. We support many formats and have converters to help you get your data into the software and use it in your depth conversion. You can also display, analyze, and edit check shock data. The data can come directly from your interpretation system, and you can view it in a chart view, analyze the individual data points, decide if they're valid, and if you have any outliers that you want to exclude, these can be removed. It will be clear in the background which data points are actually getting used in the depth conversion, and then you can choose whichever type of line of best fit suits your data best. And the function produced will then be used to create the depth conversion itself. Using the time depth trend option, you can also interpolate velocities even if you have no other velocity data available. And once we move to tie our depth grid to well data, we have a variety of algorithms available to the user here too, so they can choose what works best for their data. The correction grid and mistie report are very useful to help with QC of a well tie. The lowest closing contour option helps us identify closures across a surface. It's completely automatic and can be a very quick way to do this. Faults can be treated as sealing, as in the example on the left, or they can be treated as leaking, where we can see there are far fewer closures. You can also have a combination of leaking and sealing faults. Well knowledge is also included in the calculation, so if you have, for example, a dry hole, then no closures will be calculated in that area. Furthermore, if you have an attribute grid available to you, this information can also be taken into account to further define those closures which may be economically viable. We have quick, accurate, and auditable volumetrics. Our deterministic volumetrics can be used with a top and base or thickness grid, for example, a hydrocarbon pore volume grid. We can put in what slice thickness we want. We can have multiple contact levels in one run, should we choose. We can also set some scaling factors here if we have some idea of those. And we can take multiple polygons. Again, these can come from the lowest closing contour algorithm. When we run this, we get a QC map, but we also get a highly detailed report of the depth volume slices for our different prospects, which we can then take into Monte Carlo simulation and do more work with. The report also gives us a lot of metadata at the end, so we can always justify our decisions in future. We also work with probabilistic resources which are calculated using additional geological and petrophysical distributions to give us unrisked and risked volumes for greater analysis. The workflows within Petrosys can be automated and are repeatable. So when you update source data, you can rerun a workflow and it will automatically loop over parameters such as well tops, horizons, or attributes. In this example, we're running a workflow that is taking petrophysical data from an Excel spreadsheet, looping over those columns, and very quickly reproducing a whole range of grids that we can use for our volumetrics or other purposes. And also with our outputs, if we have something like time variant data, it can be very useful to display this in our 3D viewer to get a better appreciation of what is happening with our reservoir. These are just some of the highlights in Petrosys surface modelling. For more information, please get in touch with us.